Here are some examples of dividing rational expressions. Problem 1. Find the quotient 10n to the fourth over 7 divided by 5n cubed over 21. First, let's write this out. 10n to the fourth over 7 divided by 5n cubed over 21. Now notice that dividing by something is the same as multiplying by 1 over that thing. So this can be rewritten as 10n to the fourth over 7 times 21 over 5n cubed. Now this is just multiplying rational expressions. So first we can multiply the numerators. 10 times 21 is 210. So we have 210 n to the fourth divided by 7 times 5 is 35, and then n cubed. 210 is 10 times 21, which is 2 times 5 times 3 times 7. So 210 divided by 35, which is just 5 times 7, is 2 times 3. So we have 6 times n to the fourth over n cubed. Now there's 4 n's on top and 3 in the bottom, so dividing them, we're left with 1 on top, and we get 6 times n. So we just have 6n. Problem 2. Find the quotient 2 times b minus 3 over c divided by b minus 3 over 8c squared. First, let's write this out. 2 times b minus 3 over c divided by b minus 3 over 8c squared. Now we do the same thing we did last time. Change this into a product. So we have 2 times b minus 3 over c times 8c squared over b minus 3. Now if we multiply across, we have 2 times 8, which is 16, b minus 3 times c squared divided by c times b minus 3. Now we can cancel the b minus 3 in the numerator and the denominator and get 16c squared divided by c. Finally, there's a c squared in the numerator and c in the denominator, so we can cancel 1 on top with the 1 on bottom, and we're left with 16c. Problem 3. Find the quotient x over y cubed divided by x squared over y squared. First, let's write this out. X over y cubed divided by x squared over y squared. Now, same as before, we're going to flip the x squared over y squared and change the division sign into a multiplication sign. So this equals x over y cubed times y squared over x squared. Now if we multiply across, the numerator will be x times y squared, so xy squared, and the denominator will be y cubed times x squared, so x squared y cubed. Now notice that there's x in the numerator and x squared in the denominator, so we can cancel the one on the top with one of the ones in the bottom, and we're left with an x in the denominator, and also the y squared can cancel with 2 of the y's in the y cubed, and leave us with a single y in the denominator. Now this cancels everything in the numerator, so it's just 1 over xy.